Thanks for the intro, Umair. Um, thanks everybody for joining. Today, David and I wanted to talk about some of the best practices for automating remediation workflows. I am Pratyush. I am a software engineer at Capital One. It's been a little bit more than 7 years. I have worked on different teams that support our cloud migration journey. Have also been contributing to the cloud custodian role engine since 2018-ish. And I would like to pass it over to David for his introduction.
Hi, I'm David Shepard. So I've been doing compliance stuff at Capital One for about 6 years. And we heavily rely on custodian for that. Our environment's big enough because Pratyush works on what we call the platform team. They run the platform and make sure that all of our policies execute when they need to, real time and on polling policies. So we run both flavors, and we run multiple thousands of policies or multiple millions of policy executions a day. And we have multiple thousands of policies to implement our hundreds of controls. As a bank and as a credit card company, we obviously have auditors and regulators who care what we do and how we do it. So everything we do is under the microscope of, did it work and did it work the right way? And can you prove to us that it worked? So what we do is sensitive and important that it get done right.
Yep. Thanks, David. What if I told you that you could build a solution that automatically detects, alerts, and remediates a misconfigured cloud resource in a matter of seconds? Before we start, since everything about remediation starts with detection, I know a lot of companies, especially in the finance sector, are still evaluating their move into the cloud. And hence, I would like to ask you all some questions about your IT security. Why is vulnerability detection in some traditional IT environments so hard? It mostly comes down to two factors. First of them is lack of visibility in the environment, like who is doing what, when are they doing it, what resources are they touching, what are they accessing? And suppose there was a common framework to log actions across all the infrastructure footprints. Even with that, it would not only be hard to detect changes happening simultaneously, but also seeing what was happening in reality and correlating those actions. The second factor is a low degree of automation. In a typical on-premise environment, some services may be getting built manually, or there may be some scripting involved. Less automation leads to inconsistent patch management and potentially no decent mechanism to automate common processes in the environment. Let's look at a modern IT environment now. First thing that comes to my mind is having to work with large data sets. For example, enablement of AWS CloudTrail, CloudWatch, and AWS Config would potentially help with keeping track of all these events, metrics, and even the state of the infrastructure at any given point in time. And in the cloud, depending on how big your footprints are, these services may be generating millions, probably even billions of events on a daily basis. And that leads to a different issue, which is very low signal to noise ratio. How do you spot that needle in a haystack? Can you pick out a series of events occurring simultaneously across multiple data sources at once? The second factor in modern IT environment is the shortage of skills, meaning it's difficult to make sure that the security and development teams have the constantly updating experience and training needed for so many different systems at once. And with that, I'll pass it on to David to explain more about automation, why it's important, some of the challenges, and then finally, I'll go through the best practice. Over to you, David.
Thanks, Pratyush. So I'll do this real quick. So the question about why should you build some automated security remediation? The first one is easy. Humans aren't perfect. I can admit that I'm not perfect. No one in my team is perfect. And I've never seen a perfect developer or DevOps person. And there are some issues that you want to immediately resolve. There's some simple ones that are low risk, like, hey, I want all my RDS instances to have minor version update enabled. And I may not care about that immediately, but I want to set that automatically on like a daily policy to make sure that that's set and a window is set so we know when that's going to happen. And people can opt out of that through a standard exception system, however you do that. The other issue we run into is when things happen that a typical developer can't modify, like setting the account level S3 bucket block policy or S3 public block setting is an account level thing, and we don't allow developers to have account level access, so they can't set that automatically, and they can't change it. But if it gets unset, I immediately want to see that happen, and I set it back. So those are the kinds of things and some of the reasons why you want to do automation for that stuff. On the second part, what are the benefits? Obviously, it removes that human error. Um, it it enables you to have a self-healing environment. So if somebody goes into an S3 bucket and makes it publicly accessible, you can interpret that, you can see that happen in CloudTrail. You can set up a Lambda policy that triggers on that event and sets it back the way you want it to be kept. You never want your S3 buckets to be publicly accessible. So why allow them to be that way for even an hour? In an hour, I can pull a bunch of data out of a bucket potentially, whereas I don't want that to ever happen. So protecting that sensitive data is huge. Some of it we do for improving developer efficiency. We just don't want to have to deal with, well, I did this, but then I did this, I built it, and I built it wrong. So now I'm going to get an email or a notification through one of our monitoring tools that says, hey, you built this wrong. You have to go back and fix it. Oh, it's in production. Now you need to get a change order. Go do that before you can fix it, which adds hours to that fix event. So part of this is just shortening that time. Helping preserve business continuity. Obviously, if you want to ensure people are making backups, you need to make sure that it happens, which sometimes means you have to turn it on or kick it off. And then applying consistency in our environment, we want to make sure everything's encrypted. So we ensure that everything is encrypted. If not by default, then we force it to be encrypted to cover ourselves. And that's something you probably want to look at. I think we can go to the next one. And what are the benefits here? So the obvious benefits are misconfigurations. We all know that misconfigurations are one of the biggest problems we have in the cloud environments. There's way too many resources for us to pick those out by hand. So using a tool like Custodian allows us to see that. And if it's a easily remedied thing, it allows us to fix it immediately. So we want to make sure those things happen. We also want to make sure anything that's potentially publicly accessible, like an S3 and RDS, AMIs, EBS snapshots, we want to make sure that those are immediately addressed if they're made publicly accessible, and we turn that back off. That's just a best practice that you should all follow. Again, lack of visibility is a huge piece in this, and you know the problems with lack of visibility. Encryption is a thing, and the other part is like the idea of insider threat. If I'm an insider with a lot of access and a lot of control in that environment, and I want to exfiltrate some data, I'm going to drop into an S3 bucket, immediately make it publicly, and start pulling data out of it, right? But if I have a tool like Custodian that's watching and seeing that happen, it should be able to go through and make that bucket non-public again immediately for me, so that I don't have to suffer that threat. And we can go to the next one. And let's talk about some of the challenges. So the challenges are big. So if someone builds an RDS instance and they make it publicly accessible, it depends. If they make it publicly accessible when they first create it, I can immediately delete that resource, or I can set it non-publicly accessible. We have issues sometimes where people will build an RDS instance and not encrypt it. You can't fix an unencrypted RDS instance. So those are situations where a brand new one, you'd want to delete it. But downstream, those can have impacts if people are going to have, a multi-step process in a deploy where they're relying on that database existing to move forward. That's going to be an issue. Of course, there's exception handling, and exception handling is complex in our environment and probably more environments than people recognize. You shouldn't rely on a tag on a resource to honor an exception. That should be a separate system that the owner of the resource can't apply their own exceptions, because I think AJ or maybe Jameson wrote in there that developers are cheeky and they can read custodian code just as well as the rest of us can, and they can figure out how it is we're applying exceptions. And if that exception is, I put this resource has an exception on it, I can apply that to my resources. Don't let them do that. Use a separate tool and look up those values from elsewhere. This long-running pipelines failure, again, if you're creating an ALB in the middle of your process and that ALB is built wrong, and it's part step 3 in your CI/CD, and custodian deletes it immediately, then your CI/CD is going to fail, and then you're sending your dev team at potentially 2 a.m. in the morning to go and figure out why they failed that why their builds failed. And the other problem is you can definitely lead to alert failure or alert fatigue, where, I have let's say I have a policy that changes for some reason or something gets wrong, and I blow out, 400 alerts to a dev team. That's going to be problematic for them just to deal with the overload. So that's going to happen. And I think that's it. Go back to Pratyush.
Yep. The good news is that we are also going to walk you through some of the best practices to keep in mind when building these remediation workflows. Communication. Notification is the building block of any vulnerability management system. And when it comes down to effective communication, it should start right at the detection phase. There should be enough context, remediation recommendations, and whatnot. The context would also empower the responsible teams to understand the nature and potential impact of those security findings, facilitate informed decision making and efficient prioritization of remediation efforts. At the remediation stage, including keywords like no action required, you are no longer non-compliant, etc., have proven to be extremely helpful. Event-based monitoring, I cannot emphasize enough on the importance of continuous monitoring and real-time alerts. Real-time alerts empower organizations to respond swiftly to potential vulnerabilities. There seems to be a lot of CSPM tools out there that rely on periodic scans versus real-time scanning. Having a significant amount of lag between inventory collections, scanning those resources, and triggering a remediation workflow downstream could lead to potential disruption and unavailability of those resources and hence applications. Exception management. A control exception is the permission to continue operating a system, service, or product that cannot comply with information security policies and standards. And again, I have seen a lot of tools out there that handle the exception process by allowing users to mask a certain finding or a bunch of findings manually on the dashboard. However, when double clicking on the life cycle of a mature exception process, it is pretty clear that they're always valid for a certain period of time and are often required to be renewed or closed. And from an automated remediation workflow design point of view, it is of utmost importance that we honor a valid exception automatically as opposed to managing them manually. In other words, a user should not have to keep track of when a finding should be masked or made visible on the dashboard. Escalation handling. For every control, there should be a clearly defined vulnerability response process, and proper SLAs need to be established based on the criticality of the control. In scenarios where we are not comfortable taking remediation actions on a resource, there should always be an escalation path, like incident response. Remediation workflow should be integrated with an organization's ticketing and alerting system. Automated action. By automated action, I mean staying away from manual remediation and one-off scripts, because both of them could be prone to errors. And finally, staggered execution. As we build and update these workflows, they should be tested thoroughly in sandbox environments. And in the interest of application availability or resiliency, these workflows could impact. It should also be staggered as they roll out from non-production environment to a production environment and from one region to another. Moving on, let's look at a sample security remediation workflow for a production environment. For a non-prod environment, the recommendation is always to be ultra-aggressive, depending on how much your organization allows with regards to remediation. That would also help prevent those resources from being deployed into production. So looking at this workflow right here, as soon as a violation is detected, first thing we check is, does the resource have a valid exception? If yes, then do nothing. If it doesn't have a valid exception, check whether it's a net new or an existing resource. If net new, remediate and notify right away. If it's an existing resource, look at the criticality of the control. If the violation is critical, escalate, create an incident, whatever. If the violation is not critical, warn by sending a notification, wait until the SLA is breached, and then remediate and notify. Next, I also wanted to talk briefly about a sample garbage collection workflow from a FinOps point of view, using Cloud Custodian for all AWS services that publish CloudWatch metrics to a default namespace, using the metrics filter to bubble up some of the metrics with regards to usage, check whether the resource has a valid exception. If not, mark it for an operation, which is the mark for op action. And then once the SLA, meaning the agreed upon days are hit, go ahead and delete the resource. Finally, I wanted to go through some of the policies that could be used when building these automated remediation workflows. The first one here I would like to start with is the metric filter that I talked about in the previous workflow. And the goal here is to surface up all idle application load balancers. For the sake of this example, I am looking across the past 7 days and trying to look at the consumed LCO metrics. And if the value is 0, I mark the ALB for an operation, which is delete. And then there is another cascading policy, which looks at the same metric, and it looks for the mark for op tag and goes ahead and takes the operation. The next example that could potentially fit in your workflow puzzle is the exception handling piece. Instead of using a tag, because developers can mess with tags and whatnot, reading the exceptions from a managed list, which could be in a JSON format or a CSV format, and custodian allows you to read from a file on the fly and whatnot. This is an example for a Lambda that would potentially look for unapproved AMIs, and the definition of unapproved is, in this case, is the AMI not being owned by the account, right? Moving on to the next example. This is another piece that I wanted to highlight, matching or applying event bridge rule pattern. So in this case, we are looking for a pattern that says capacity provider, could be Fargate, Fargate spot. This way, we are able to potentially put a tag on ECS task definitions that are actively running on Fargate, and then have different controls run downstream on those ECS task definitions. And finally, I wanted to highlight or show off Custodian's native integration with AWS Security Hub. The example policy on the right is flagging a cross-account snapshot, and it is logging a finding into AWS Security Hub. You can have all sets of metadata, all sets of attributes in there, recommendations, and whatnot. The compliance status in this example says failed. Keying off an automation of this finding, I have something on the next slide, which is triggering off a Lambda or invoking a Lambda that would re-look at that snapshot. And if a user decided to fix it, it would go and change the finding in Security Hub from failed to passed. And the screenshot on the right side will show you a lot of different metadata that we want to capture as part of that finding. And with that, that's all for this presentation. I'm happy to take any questions, and thank you all for your time.